Morning, everyone. It's a bit early to talk about advanced topic today. So what I wanted is just to give you an introduction to these concepts, and hopefully by the end of this session, you get to know what you need to do in terms of taking your Kafka applications to the next level. So the fact that you are here in this session, I would assume you probably know or worked with Kafka before, and you're trying to get the most out of Kafka applications. And to be honest, it's not easy job. Stream processing in general is not easy to learn, let alone scaling or even doing enrichment for Kafka applications. So my goal today is just to simplify this process and make it easy for you to understand first of all, but also like you get something out of it. So even if you don't work with Kafka or you don't work with stream processing, you probably get to know how real-time applications work and essentially what you need to do. The question becomes here, why you need to do it, why you need to learn about real-time application, why do you even care? Simply because now most applications are moving to real-time. And it's not easy to do it. So if you imagine like normal application or batch application where you have, maybe a microservice or, a standalone application and you connect it to your database. So the way it works, you ingest your data from somewhere and then you basically write it to a database or a file system, right? And then you load it back again to your application into memory. You do some analytics on it, and hopefully you give some kind of results. So this is not what we're talking today about, and it is important to move or shift from batch applications or batch mode to real-time applications. So my name is Fawaz Ghali. I lead DevRel at Hazelcast. And I traveled from the UK simply because I wanted to highlight why this is important, why you need to learn these type of skills. So just to get things started and to give you some kind of warm-up, anyone wants to guess how long it takes for Formula One cars to accelerate from 0 to 60 miles per hour? Couple of seconds. Yep. So on average, it depends on the model and the driver and so many aspects, which we call features. It takes about 2.5 seconds. So that's roughly around 2,500 milliseconds. So notice I didn't say 2 seconds or 3 seconds. I specifically say 2.5. And this zero point 0.5 is very crucial and it's very important because if, for example, you try to take average and you say 3 seconds, that's like half a second slower. And it is important for Formula One races and so on, but also for other aspects. So it's not only about Formula One applications, but also for any mission critical application. Now you might be thinking, what type of mission critical applications? So this is kind of like, as end users, not as a developer or solution architect, we tend to do these type of actions. So for example, I don't know, like maybe you do some kind of online banking, you log into your bank, whether it's on mobile or internet, laptop or desktop. So it takes time to log in and you do transaction, and or even like you do it like physically with ATMs. So this type of actions require to have a real-time features integrated. And obviously not only banking, but you see it also shopping, for example. I'm not talking about physical shopping, but mainly about online shopping, obviously. So if you try, for example, to look for a product on a X website, I think X is the wrong word to use here. So on any website, basically what you do is you look for products, you get some recommendations, you place it in your shopping cart, and by the time you click buy, the bank and the system and the application needs to validate it and send response to it. Again, Ford is part of it. Even if you look at your application, so think about the current application you're working on. do you know when your application is going to fail? Or do you know how much you want to scale it? Or how much resources you need? And do you know on average how much, for example, CPU you need, or how many transactions you need? And even if the answer is yes, you probably know the average. So you say, I have 1,000 transactions per day, per week, whatever time frame you want to use. But that doesn't mean you're able to handle or predict spikes in your application. So for example, Black Friday events, online offers, all these aspects cause spikes in your application, and you should be able to handle it, right? And even if you look, for example, some kind of applications where you use some kind of like Uber or any type of, en route travelers, flights, and so on, they use real-time application. So there is a concept that you need to be aware when you deal with this type of application, and it's called time decay. So what do we mean by time decay? Essentially, it doesn't matter which application, even if you're not working in this area. Basically, the longer you wait, the less value this information has. And it's, to be honest, it's applicable to any concept or any domain you're dealing with. So for example, if I ask you now, let's just say about last week, for example, do you remember where you were last week? Maybe yes. Maybe the answer is yes. So if I ask you more details about these types like of events you've been to, or actions you did, and so on, obviously, the longer I ask you for, the less value it means, because like the actions you did last week is more valuable to you to decide compared to actions you did 1 year ago or even 10 years ago. So this is basically on weeks or years, but the same concept applies, right? So if I'm doing online shopping now, I really want to know which products are relevant to my search at this moment. I don't want to know about products I searched for yesterday because it might be not relevant. And same thing, if you go to some social websites, sometimes you get recommended items. And if you're, for example, on a video website, sometimes you get weird recommendations, or on some kind of tweets or whatever application you use. The feed itself might not be relevant. And if it is like, one time off, that's fine. You might call it a problem or hiccup in your application, but that's not the case, right? And from time to time, you get weird recommendations for videos which are not relevant to what you've been interested in or you want to watch. Why is that? Why do you get unrelated information or unrelated recommendations to what you've been doing or what you're looking for? And the answer is simple. It's basically time decay. Essentially, the algorithm is not able to detect in this moment what results it should give you back. And it is a journey. It is not like, yes or no, I want this information now or not. It's basically a scale, and it is multiple steps, right? So it depends which step you're on. So to give you some kind of rough idea from where we're going from to where we want to go to, if you look at one axis for this figure is basically the value, and the other one, the x1, is basically the time. So most of us live in the batch area, or batch mode. So basically here, the information by itself doesn't have any value if you want basically to take most out of it. And essentially, it is very slow. If you want to think about it, how long does it take for you to load X events from your database? Could be seconds, could be milliseconds, could be days, could be hours. Who knows? It depends how many transactions, right? But it is a slow process. Why it is slow? Simply because if we just forget about the application, we have a problem or delay in the hardware, right? Between reading from hard disk, loading it into memory, this process takes time. So some techniques are basically trying to solve this problem, and it is something called streaming ETL, which is like OLAP or OLTP. Essentially, what they do is say, hey, I want to do some analytics on my data. Let's just create some kind of database, store this analytics in my database, on new database, obviously, and this will speed up the process, right? Yeah, it used to work fine in early 2000, but we want to shift between this dotted line, you see it, horizontal line, you see it on the screen. We want to move from delayed action to instant action. So what do we mean by instant? Essentially, you need to process the data as soon as you receive it. And this is very important because what we're trying to do here is to minimize latency. And we hopefully agree now you can't minimize hardware latency. So hardware, for example, reading from disk or reading from a, for example, I don't know, a different AZ availability zone or different region. So all these aspects come into place. And obviously, we want to move to real-time applications. So this includes, obviously, machine learning. Now, if it is you in this process, you might have a perfect application, right? We're all proud of our applications, but that's usually comes with a big but, right? So this but could be related to how you take it from development to deployment. And this is not easy to do or even not easy to scale, even if you have auto-scaling enabled. Or maybe kind of like if you have machine learning model and you want to serve this model. So taking model from training to testing into production, you might get completely different results. And that's the exact why it's happening for unrelated recommendations. So what I want you to think about is the process between having a problem or a use case and getting results. So this process is not straightforward. In order to move from, creating a code or a microservice and then getting some results out of it, it's not straightforward. It's not like you write code and you get results. There are so many elements in it, and usually it's a roller coaster, so it goes up and down. And you want to not only think about deployment, but how do you monitor it? How do you, for example, know in this moment what memory usage you have in order to do auto-scaling, for example? Or do you really need a cluster of 10 nodes or 5 nodes? And do you know how you can, for example, analyze your logs in real time? Not to store it into database or file system or hard disk, but to actually analyze it in real time. So hopefully by now you understand we're working on two different types, right? So we have the real-time data, and this data is fast. It's not like, minutes or even seconds. It's pretty fast. It's sub-milliseconds we're talking about. And we have also historical data. Now, historical data refers to data stored into database. So real-time applications don't mean, only working or processing real-time data, right? So that's what Kafka is. And I'm going to explain in more details, obviously, what you need to scale up this process or level up your Kafka applications. But there is an element attached to it, which is basically how do you get context out of it? So for example, say you have type of events. So for example, I want to place some orders online, right? And I want to write a microservice to recommend related products, right? So related products could be related to the actual product I'm looking for. So for example, yesterday I was looking at training shoes, running shoes, right? So I would like to know, for example, which running shoes are relevant to my search. So this is real time, which means you get real-time recommendations for exactly what you're looking for. But that's only part of the story, right? Usually recommendations not only about the real-time data, but also more on the contextual process. So for example, how old I am or how fast I am, for example, to determine what shoes they need to recommend. which terrain I need to run on. So all these elements don't come from the search query I put in, but mainly from previous orders I placed, or for example, my favorite brand, and so on. So that's the historical. Now, in order to write these applications, obviously you need architecture, right? So if you are a developer, for example, there are some cool sessions today about microservices. I would encourage you just to, get up to speed with microservices, because it's very important for real-time applications and large-scale applications. And also like event-driven applications. So essentially, you have a source of your data, right? And you have sink. So event-driven applications mean you actually disallocate your source and sink. Essentially, you end up with a synchronous application. So you read your data, maybe you store it in some kind of queue architecture, and then you process it at different speed. And this is very important because usually in order to do this type of events in real time, you need a really fast architecture. And microservice is, exact architecture you want to use. It's one of the best, right? Or you can use event-driven as I described. And even if you don't have large application, you still need to split your architecture to something called DAG format. So if I want to write a web application, for example, maybe I have a microservice to read from database or Kafka. Then I have another microservice to do maybe some analytics, and then maybe another web service, or microservice to do visualization. So splitting my application into multiple microservices allow me essentially to move or connect multiple. So I can basically take my data input from one microservice and send it to analytics at the same time to visualization, for example. Of course, it's easier to build and maintain if you have large team, or if you're working with large team, it's easier to deploy as well. And of course, it is very important in terms of performance. If you remember exactly what I mentioned about the delay and time decay, microservice allows you to actually speed up this process. Now, why do you need to use this type of architecture? The answer is, how do you scale? So if I now ask you, what does scaling mean to you? Some of you will say, hey, my understanding for scaling is I want to be able to scale my process or my code, which is fine, right? But for the rest of you, you might say, no, it is not for a process, it's mainly for my data. How do I scale my data? Say, for example, you have multiple data sources, and how do you actually be able to use or scale your sources? And the right answer, basically combination between the two. So you need to be able to scale your data, and you should be able to scale your compute. And not only to scale both, but also to be able to minimize latency. So how do you do it? Essentially, if you have two microservices and you have two data sources, what you want is to have multiple regions, right? So say for example, I have a data center here in Prague and I have a data center in the UK. I want to be able to have a microservice related to the data in Prague as close as possible to this data center, and same thing for the data center in the UK, because I'm trying to minimize latency. And this will allow me to deal with multiple Kafka topics, as we'll explain. Now, the cool thing about it, there are so many ways to do it in microservices. So I'm going to give you 3 now. You can take it home if you want and start, play around with this type of architecture. So essentially, you don't need to change your code. What you need is just to have it in a microserver architecture, and then you should be able to do these concepts. So first mode is the embedded mode. So you have, say for example, n microservice, and you need to run it in embedded mode, which means you should be able to run it within your cluster. If you're a Java developer, and I assume majority of you are the Java developers, essentially you have a jar file, you add it to your code, and then you can basically run it in embedded mode. So this is very important, and essentially all bank and payment system use this because it gives you the option for ultra low latency. Now the other option is to use client mode. Essentially you just disarm these microservices from your cluster, and this allows you to be able to scale your cluster and your compute separately from your microservices. So you have microservices, but not in embedded, it's in client mode, and then this will allow you to change whatever you want to do on your cluster and your nodes. Obviously, the best is to get both out of these two, which is basically a pipeline mode. Pipeline mode allows you to run it in client mode and embedded. So you have it as embedded, and then you run it in client mode, which allows you to be able to have it as part of your cluster. Okay, so that's first part of this session today. Let's just move to Kafka. So I would assume now that you know Kafka or you dealt with Kafka. And the question is Kafka enough for your application? So if we look at it, Kafka is great, right? So you can move your data from A to B, for example, or you can do event sourcing. So you can have some kind of IoT device or smart device. You read your data and you ingest it in a Kafka topic, and then you connect it to your application. Or even if you're a data scientist, for example, or machine learning engineer, you can build a pipeline based on Java and Kafka. Java is just one way of doing it, right? Some of you who have some really good experience with Kafka know that you also can do stream processing. But I intentionally left it out of this because it's part of Kafka is to be able to do stream processing, right? And you can use, a library for it called Kafka Stream. But even Kafka Stream is limited to what you can do for real-time applications. And I will show you what I mean when I get to point. But what I want you to take away from this slide is if you're dealing with Kafka in general, or if you have a Kafka application, you're probably not using most out of it. Maybe not today, maybe not next week, but at some point your boss will come to you and say, hey, I'm not happy with the results of your Kafka application, whether it's performance, whether it's functionality, or even for real-time application, which is what we're talking about. So I'm not gonna discuss today performance. I'm mainly focusing on functionality and how you can basically simplify this process. So let's take example, right? I want to take some money out of my card, and I want to use ATM, so a machine basically. So I take this card, I swipe it, I put my PIN code. This request goes to my bank, it validates it, and then gives results back, right? So you read your data, ingest it in Kafka. You need to enrich it. I will show you what I mean. You need to do transformation, and you need to do prediction, and then you need to decide if it is false or not, if it is fraud or not. So this is basically where Kafka comes into place. So Kafka is great. You can ingest this transaction or ATM event in real time in Kafka. But if you want to do some kind of data enrichment, and data enrichments for this use case may be related to some events related to your bank account. So what is your credit score? How many transactions have you done in last day? Where are you located? Where is the GPS or what are GPS coordinates for this ATM machine, and so on. So all these elements are not relevant to real-time events. Real-time events for ingesting data could be related to your card number, PIN code, for example, and so on. Whereas enriching the data is more about you as a user. You need to do data transformation. So for example, if we look at how much money you want to take out of your bank account, for example, say, I don't know, 100, 200, 1,000, and so on, and compare it to number of transactions, maybe 1, 5, 10, you see the point here, right? So the number of transactions are not the same as how much money you want to take. So what you need to do is to do some kind of normalization if you're a data scientist, or do some kind of data transformation to change the structure. Then you need to do prediction for it. So which machine learning model you want to use, which features do you want to use, GPS coordinates, do you want to use credit score, and so on. And all this comes into place to actually decide to validate it or not, right? So it took me about 3 to 5 minutes to explain this event, right? But your bank needs to reply with sub-milliseconds. Usually, on average, it takes around 50 milliseconds or 100 milliseconds. So this is 1/10 of a second. So this is pretty fast. So by the time I say fraud, your bank needs to decide if it is a fraud or not, even before. So if I say fraud, basically it's faster than saying the word fraud. So hopefully this gives you the idea why you need to actually think about your architecture, right? So there are two ways to do it. And my advice, based on my experience, is to look at the learning curve. So learning curve is essentially how long it takes you to learn X technology. So it could be Kafka or could be anything else. It doesn't matter for these concepts here. So say, for example, your boss comes tomorrow and say, hey, we're gonna use this technology. You say, I don't know it. Of course, they give you some kind of time frame, give you 1 week, 1 month, whatever, to learn it, right? Now you need to multiply this time frame by number of tools you need to use, right? So if I ask you now, I want you to use 3 technologies now, which you don't know anything about. So now learning curve becomes 3 times more. And this is exponential, right? Which means the more tools you need to learn, the more steeper this learning curve is. So there are 2 ways to do it. So first way is DIY, which means basically you do the plumbing job for it. It doesn't matter which team you're working on. Essentially, what you need is to use multiple tools to do real-time stream processing. So looking at it in this screen, we have Kafka as source, but could be AWS Kinesis, for example, or it could be Apache Pulsar. So all the same, right? But if I ask you now, not only Kafka, maybe you don't know AWS Kinesis, or you don't know Apache Pulsar for this matter. I want you to read from 3 resources, and suddenly you need to learn these 3 resources. So this adds, of course, learning time, development time, and maintenance time. Because what do you do, or how do you fix issues? Now, ingesting data is first part. Second part of it is to do stream processing. So you can use, I don't know, Flink for it. And Flink is great, again, for stream processing. But if I ask you, I want also to be able to read batch data, right? So maybe you use Redis now, or you use Cassandra, or whatever tool you want to use, or framework. And now you see the point, right? You need to know all these technology to do real-time applications. Now, if you think about it for a second, this is just part of it, right? Because you still need to do feature engineering, maybe not you, maybe different team, or you do machine learning, so you need feature store added into it. You need data lake, and you also need to do visualization as well. So if you are really working on large-scale applications, it doesn't matter if it is real-time application or not, I want you to think about large companies. I know this, this talk is being recorded, so I'm not going to name companies here, so feel free to reach out, or I'm going to stay outside to discuss it more. If you look at large companies, why large companies build in-built housing applications, or even they don't outsource their applications? Why they built it in-house? Simply because they try to avoid the DIY approach. So they found if you actually want to use or create an application which requires you to use 2 or more, I don't say 3, but you can count how many applications here on the screen or framework. If you're gonna write an application and it requires you to use 2 or more tools, regardless how good these tools are and how best in terms of performance, benchmarking, and so on, you need to do all this multiplied by number of tools. So again, learning the tools, doing the development, doing maintenance. So good luck with it if you want to follow this approach. It is possible, but again, there is a really crucial element, which is higher latency. Because if you have 2 applications or 2 frameworks, there is a connection between these 2 frameworks, right? So even if you're actually optimizing these 2 frameworks, and these 2 frameworks need to connect in some way. So for example, Flink and Redis, right? So Redis is optimized, Flink is optimized, but do we know if Redis plus Flink connection is optimized? Of course, this is like an idea to start up, and most startups actually use these concepts. So what they do is they use multiple technologies to create a new tool or a new product, and they launch it. And this new product, of course, is faster if you do it yourself. It's not faster than Flink, or it's not faster than Redis. Essentially, it's faster than Flink and Redis. So this is kind of like the idea of using a one unified platform to do it. You don't need to use multiple tools for the same job. So it doesn't matter which tool. My recommendation for you is to go out and try. So this is the only way to know which tool you want to use for real-time application. Now, real-time application, you say Kafka, Flink, they do stream processing, and that's pretty much what you need. Cool. But you still need to load contextual data into your application. You still need to know why this transaction, or what are the details of this person or this user who is doing this transaction. Or for example, the features of this theater and so on. So if you're not sure, or if you're not heard of Hezecast before, so Hezecast, open source unified data platform, exactly does this job for you. So essentially what you gain out of it is simplified architecture, which allows you to do stream processing and fast data store. It's one way doing it. Obviously, I'm going to show you how you can do it in real time and show you why it is important to connect multiple sources. So it could be Kafka, could be IoT device, could be enterprise application, could be database, and why you need also to be able to have a fast data store. So the fast data store component, as well as stream processing, are actually in one platform, which means there is no latency between the two. So it's exactly if you have to use 2 tools, but you get most out of it because you're trying to minimize latency. And this is very important. If you want really to enhance your career, you need to move from 4 nines to 5 nines. So from 99.99 to 99.999 applications. It doesn't matter if it is Hezecast or which platform you want to use, but we want to increase the accuracy and minimize latency in order to do these applications. You can connect it to multiple clients. So I come from data science background. So my background is data science. So I'm going to use SQL. I'm going to show you in Java how you can do this type of applications and enriching Kafka and why you need to do it. And then you can simply output it to different sources. So to explain the architecture here, I want you to think about a Kafka topic, essentially just a message bus, right? I'm reading this data. And as soon as I read it, I load it into my application. And then I'm using Python as service, or mapping using service, essentially to connect it to a machine learning model or more. And the answer is always more. So you always need to use multiple machine learning models. So those of you who have machine learning background, come speak to me afterwards. I can explain more details why you need to run it this way. But in simple terms, you need to run your machine learning model on top of Python virtual machine and your application on Java virtual machine. So don't ask me now on Slido Python versus Java. I'm not going to answer that question, but I will answer it outside again. So, but I want you just to think about it as connecting machine learning models using to do prediction or recommendations, whatever, to your application, and then hopefully sends results back out to a different Kafka topic. So let's just go through the architecture quickly. So my data is coming from Kafka, and I want to load it into my application. At the same time, I want to do data enrichment. So data enrichment essentially comes from a database or a file system, but essentially you need to be able to have both data types, both events in memory. And this is very important because it allows you to do this enrichment in real time without accessing database. And hopefully you can see your results. So if you want to run it, you need Kafka installed, you need Hedacast installed, but the concepts are the same regardless if you use Hedacast or not. So the configuration part is easy if you're using Java. So you have to use properties. On my demo, I'm using my laptop, so I'm using embedded mode to do all this work. But you simply can use client mode, or you connect it to any cloud provider. And my advice is, if you really want to get really good at it, use a cloud provider. It doesn't matter which cloud provider, because we're trying to minimize latency. And it is faster to load every data type or every data source into the cloud and process it, because this allows you to do it in much faster way and minimize latency, so you don't keep loading it. Now you can use Kafka as a source or as a sink, and this is how you can do it in Java. So essentially you say, I want to read my events from Kafka topic, and then I want to sync it. So my job today is just in between these two steps, right? I want you to think about how much you can do between these two steps and how fast can you do it. You say, I don't want to work on Formula One cars. That's fine. How about online shopping? How about fraud detection? How about banking? How about smart devices? How about machine learning? Or how about even sports? Those who follow football, for example, VAR use sub-milliseconds. So if I ask you now, open your mobile and choose random 10 applications, the chances are 8 out of 10 are using these concepts. So we want to do all these processing in between these two functions here. So let's just jump quickly to my screen. I'm gonna explain what you need here, and I don't. So in here, hopefully you can see it. So I'm using Java. So this first step, I'm saying I want to integrate it with Hedacast. So in your case, you don't change your application. You just import a jar file in embedded. And I have a publisher here. So this publisher allows me to connect it to Kafka. So this is what you need. If you haven't worked with Kafka before, you need just to set up properties for it. So I'm saying I'm running it locally on this port. I'm using serializer. And this is very important because it allows you to gain performance when it comes to do a stream processing. So here I'm generating events. So let's just run it. So now you can suddenly see these events in real time. So 24, 26, 31, 32, 34, and so on. And I want to process it. So in my application, I create a pipeline. So of course, I import all libraries. So pipeline, in your case, is exactly what your application, current application, is doing. So you don't need to change it. You just need to use a Lambda function, if you're familiar with Lambda function, in order to write this pipeline. So this pipeline reads from Kafka. Of course, I'm applying window on top of it. Why I need window? Because batch data or database, you know, if I ask you how many events you have in your database, you do count, you give me 1,000, 2,000, and so on, we're good. But if I ask you how many events you have in your stream, do you know the answer? Of course not, you don't. Maybe you know the starting point, but you don't know where it's gonna end because it's a stream. So what you can do is use windowing. So you say 10 events, 1,000 event, and then you slide this window. So you say, I'm gonna slide it 1 event per second. So you can slide per time, or you can slide it per event. So every 1,000 and so on. So if I run it now, You see this type of, I'm just doing counting here, right? So this is kind of like aggregation. Think about it. So it tells me here 5, 4, 7 events per second, 5, 4, 3, 7, 10, and so on. So you get the idea. I'm just doing counts, how many events I'm getting in 1 second. But that's just part of story. What does it mean I have 5 events or 10 events per second? Think about it if you're doing fraud detection. Does it mean anything to know that you have 4 fraud events that you need to flag, right? It doesn't mean anything, right? Because why you want to flag it as a fraud? Or even if you know the answer, I want you basically to enrich it. So this is exactly what we're going to do today. So I'm gonna stop this process here and switch to SQL to show you how you can do it in SQL. You don't need to use a SQL, you can use Java for it. So on one side, I'm gonna change here and change here. So on this side here, first of all, I have Kafka running. So for Kafka, you need a zookeeper for it, and you need the Kafka server. So these are running now. And I have Hezecast instance running in the back. So if I show you my code, I'm gonna generate these events in real time. So random events in SQL, right? SQL, you might think about SQL as a way to connect it to your database. Today is different, right? So I'm gonna use SQL to connect it to a different application, different use case. So this SQL will use to generate data and store it into map in memory. And at the same time, I'm creating another map, which is the historical data. So this is where enrichments come into place. So I have my transactions, but I also want to do data enrichment. So I want to flag some events as red, blue, or green. So for me, red means this is a fraud activity, right? Now, because it is a batch data, so you see it now, this is not generated in real time, so one time off. So I created a map, and this map has set of records. So this is exactly how your database is. You load it into memory, and now you have 2 different types. So if I say, for example, give me these events for event 2. So for example, from this stream, I'm gonna increase this size here so you can see your results. So I'm saying, just give me events, right? Tell me how much the transaction is and how many elements in it. So here just you see event 2, right? So event 2 has value of 12, 14, and so on. So these are in real time and how many items are bought or whatever. So think about it as real-time data. So this data is coming from Kafka into my application, right? But I want to know which of these transactions should be flagged as fraud. If you're using machine learning, for example, you need to connect machine learning model. You can use linear regression, for example, or some kind of classification, decision tree, or random forest to do it. In my case, again, I'm just trying to simplify it here. I created a map. I put data, historical data, into this map in order to make it fast to process. Now, the second command I want to execute is the data enrichment. So this is how you can take your Kafka application to the next level. So you're not only processing the real-time data, but also at the same time combining it with historical data at the same speed in the same application without the need to change any part of your code. So it is, if you know SQL, and I hope you know, if you don't, please try to actually see how SQL works, because it's important to speed up some processes, even in some use cases faster than writing a code. I'll give you some examples here. This is off topic. Obviously, it's always important to analyze your data before you write your application. Even if you don't work with data and you have data engineering team, it's important to understand the data itself. So in my case, what I'm doing here, I'm saying I want to join 2 different types in simple join statements in SQL And I'm adding this condition here, you see. So not only any event now, it's not only event 2, but also the events which are flagged as red. So this red comes from the second map, which is this one here. Now, just to show you what happened here, so this data is still running, right, in background. So I still get these events and transactions in real time, and now I want to do the data enrichment to flag only red. Not this one here. So sorry, apologies. So that's not the command I want to run. I want to do the data enrichment. Okay. Let's go back again and do this data enrichment here. And now I'm connecting between two maps. So there is no element of database in this application at all. And between the results you see here and the results you will see now. And now, if you look at the third column, which is this one here, I don't know if you can see the mouse. It's where you see red on the screen. So this is basically to flag only events. So we still see all type of events, but only we're flagging the one which are red. Now, by the time we combine between these two different types, actually we take this stream processing from Kafka to do stream processing with Kafka and historical data in one platform. Now, there is more to it, obviously. I'm going to wrap it up quickly in order to take questions. But obviously, if you are interested in doing this type of architecture, you can use some kind of two maps. And you can also, we have Slack community for the open source, so feel free to join Slack. We do Twitch from time to time. Twitch is kind of like informal, fun discussion about stream processing use cases. So it's like you don't get to speak to our engineers or solution architects to see how it works, and you can also ask questions there as well. So thanks very much for listening. Hopefully it was useful. The key takeaways for this session is, first, you need to learn real-time applications. Maybe you don't use it today, but at some point you need it to add it to your CV and definitely enhance your career. Second, it doesn't matter which streaming processing framework you use. If the answer for a use case is one platform, feel free to use whatever you want. If the answer is to use two or more, think about it, because it's going to take you longer to learn, to develop, and to maintain. And finally, the part where you enrich Kafka. So if you're working with Kafka and you currently have some kind of stream processing on top of Kafka, try to get most value out of it, because it helps your end users or even your boss. It will make him happy or her happy in the end of the day. So thanks very much, and I'm happy to take questions in 2 minutes or so. So feel free to leave your questions on here. So no questions at this point. So I'm going to stay outside. If you have a specific use case, or it's like dedicated use case you want to learn more of, if you want to learn more about these concepts, whether it's related to machine learning, Java, for example, or large applications, or if you try to minimize latency on your applications, again, it doesn't matter if you're using real-time or stream processing, come speak to me. I can give you some ideas. There are some good talks about these type of applications today. I believe there is one at 11 o'clock. So again, attend it if you're interested in these type of applications. And also, finally, one word is just to make sure that you actually take whatever you use now and move from batch to real time. So thanks very much. Hopefully it was useful. Thank you.